In this video, we'll see how to solve one-step equations by addition and subtraction. So here are the general guidelines for solving any equation, not just one-step, but two-step, multi-step equations. The goal for solving an equation is to find the value of the variable by getting it alone on one side of the equation. So to solve equations, you simplify each side of the equation using the distributive property and combining like terms if necessary. Step 2 would be to get the variable term alone on one side of the equation by zeroing out the constant. This is the step that we are focusing on today. We'll be doing this. Step 3 is to isolate the variable. That means you want to make the coefficient 1 by multiplying or dividing by the coefficient. And then check your work by substituting your answer back into the original equation. Property we're going to use a lot is the additive inverse property. This is a very important property for eliminating those constants, zeroing out those constants. And what the additive inverse property states is the sum of any number and its inverse or opposite is 0. So we have a couple examples here. 8 plus negative 8, that's 0. And x plus negative x, also 0. Here are some practice problems to try out here. I'll walk you through how to work with these. M minus 9 equals negative 14. So what I want to remember, what I do with equations is what I do to one side of the equal sign, I do to the other. And I want to zero out this constant here. This constant is negative 9. To zero that out, I think about the additive inverse property. So negative 9 plus 9 is 0. So on the left side of this equation, I just have m left because m minus 9 plus 9 just equals m. But whatever I do to one side, I must do to the other. So I also want to add 9 to the right side. Negative 14 plus 9 is negative 5. I can check this by substituting this negative 5 in for m in our original equation here. So negative 5 minus 9, that is equal to negative 14. So it checks out. This next example, I have 42 equals 12 plus w. Again, I want to zero out my constant that's on the variable side. That constant's 12, a positive 12, so to zero it out, I'm going to subtract 12. But I also need to subtract 12 on the other side, because what I do to one side of the equal sign, I must do to the other. So 12 minus 12 plus w just leaves me with w. Carry down my equal sign here. 42 minus 12 is 30. I'm going to check my work here. I'm going to substitute 30 for this w here. So 12 plus 30, that equals 42. And again, it checks out. Then I also want to solve this next example. It has some fractions in it, but still, the concept is the same. I want to get the variable by itself. I want to zero out this constant of 11/15. So that's a positive 11/15. To zero it out, I need to subtract 11/15. And I also need to subtract 11/15 from the right side then. Now these two constants zero out, leaving me with y. 2/5 minus 11/15. I need to change this so we have a common denominator. So I get 6/15 minus 11/15. 6 minus 11 is negative 5 over 15. That could be reduced to negative 1 over 3. So y is equal to negative 1 over 3. I can check this. I can substitute in negative 1/3 for y plus 11/15. I need a common denominator. That's negative 5/15 plus 11/15 is equal to a positive 6/15. And so that also checks out because 6/15 reduces down to 2/5. All right, here are some problems for you to do on your own. Complete these three. Hit pause while you're doing that, and then hit play once you're done, and we will walk through the examples. Okay, now that you've finished these, let's take a look here what we would do. I want to get this k all by itself on one side of the equal sign. It's k, I'm subtracting 14, so to zero out that constant of negative 14, I want to add 14 and do the same thing to the other side of the equal sign. I'm left with k on the right side, and negative 33 plus 14 is going to be a negative 19. To check my work, I'm going to substitute negative 19 for k and subtract 14. And when I solve this, negative 19 minus 14 is negative 33. So that checks out. In this next example, I've got 3.8 equals n plus 5.2. I'm going to subtract this constant 5.2. I'm going to take 3.8 minus 5.2. 3.8 minus 5.2, a good way to think about it is just switch it around. Let's do 5.2 minus 3.8. 12 minus 8 is 4. 4 minus 3 is 1, so I get 1.4. But since it's 3.8 minus 5.2, it's going to be a negative 1.4. And then on the right side, n plus 5.2 minus 5.2 is just equal to n. So when I want to check my work here, I'm just going to take a negative 1.4 and I'm going to add 5.2 to that. So I want to think to myself, well, what's 5.2 minus 1.4? 12 minus 4 is 8. 4 minus 1 is 3. That's equal to a 3.8, so this checks out. And finally, for my last example here, negative 3.7 equals r plus 2/3. So one thing you can do to save a little bit of time and keep your work nice and neat is find the common denominator right away. So I'll show you what we would do there. I know the common denominator between 7 and 3 is 21. So negative 3/7, if I want to change that to a fraction with 21 in the denominator, I have to multiply 7 by 3, so also multiply 3 by 3. I get negative 9/21. R plus 2/3, I want to change that, so I've got 21 in the denominator. So I want to multiply 3 times 7 to get 21. 2 times 7 is 14. And now I can just subtract here. R plus 14/21 minus 14/21, and negative 9/21 minus 14/21. These zero out, leaving me with just r on the right side. Negative 9 minus 14 is negative 23/21. And I want to check this work here, so I'm going to substitute back in. I'm just going to use this equation where all the denominators were the same, just to make it a little faster. So I'm going to substitute negative 23/21 for r, plus 14/21. Negative 23 over 21 plus 14 over 21. That is equal to negative 9 over 21. And if I divide the numerator and denominator by 3, that's equal to negative 3 over 7, which checks out to our original problem. And that is how we solve one-step equations with addition and subtraction.